This video is on section 3.1 planes. It will be the first, last, and only video from section 3.1. And so definition 70 is what a normal vector to a plane is. Vector is normal to a plane if it's orthogonal to every line in the plane. And theorem 71 tells us how to find the equation of a plane if we're given a point on the plane and a vector that's normal to the plane. So a normal vector to the plane has components a, b, c, and the plane contains the point x sub 0, y sub 0, z sub 0. What's the equation of the plane? We take the components of the vector as our coefficients a, b, and c. Then we have x minus the x coordinate, y minus the y coordinate, z minus the z coordinate. That's the equation of our plane. So a very straightforward example is part A of example 72. We're given the point 1, negative 1, 0, and the normal vector 1, negative 2, negative 1. We want to find the equation of the plane that contains this point and has n as its normal vector. We simply use this equation right here. So we just plug in the numbers in the appropriate places, and in the next line down we just simplified slightly. So this is the equation of the plane that contains this point and has this vector as its line. So any point in R3 that satisfies this equation here is a point on the plane. So specifically, if we simply substitute 1, negative 1, and 0 in for x, y, and z here, we end up with 0 equal to 0. So we just verified that this point actually is on the plane, but we knew that because we used the point to find the equation of the plane. The second example has a few more steps to it. We're given 3 points on a plane. Now remember, 3 non-collinear points define a plane. So think back to when you studied lines. You can find the equation of a line in 2 space if you know a point on the line and you know the slope. Well, what happens if you're given 2 points? If you're given 2 points, well, you use those 2 points to calculate the slope, and then you can use one of those points in the slope to find the equation of a line. When I first give that example to students, it's one of those examples that sometimes I like to tell students, you already know how to do this problem, you just might not know that you know how to do it. And so it's a similar thing here. I think you already know how to find the equation of the plane containing 3 points, you just might not know that you know how to do it. So first of all, let's find a couple vectors parallel to the plane. So v is the vector 0, 0, 2. Where did that come from? That is the vector with initial point 2, negative 1, 1, and terminal point 2, negative 1, 3. So the vector that starts here and ends here is this vector right here. W is another vector. So we find another set of 2 points to be a terminal point, to be a starting point and a terminal point. And so if we use this as our beginning point and this is our end point, then we have the vector 1, negative 2, 1. And you can use any pair that you want. You just have to use 2 different pairs of points. So you find 2 vectors, then you take their cross product. Remember from the last section, the cross product of 2 vectors is orthogonal to both vectors. This vector is parallel to the plane, this vector is parallel to the plane, this vector is orthogonal to both of these. So now we have a vector that's orthogonal to the plane. I didn't use this vector, I used a scalar multiple of it. So just multiply this vector by 1/2, and we have the normal vector 2, 1, 0, makes the coefficient smaller. Nothing wrong with this vector. It's orthogonal to the plane as well. It's normal to the plane. This is a normal vector to the plane, but so is this one. This one's easier to work with. So now we just use our formula. We have a vector and we have a point. We have 3 points. Pick whichever one you want. I picked the first one. So we have 2 multiplied with x minus 1 plus 1 multiplied with y minus 1 plus 0 multiplied with x minus 0. And simplify this a little bit if you want to, but that's not necessary. I don't have a whole lot to add in the video to definition 73 and theorem 74 through 76. They're in the notes for a reason. I don't want to say, gee, this isn't an important part of the course because I'm not doing the video. It's just that it's written in your notes and you don't really need me to talk about it for you to read through those. So I want you to study these, I want you to read through these, and if you have any questions, then ask me in class.